All right, this video is going to go over 9.2b notes, which is more rationals. So let's go ahead and get started. You need to remember the parent function. And so like you're just plugging in these x values and getting a y value. So this time it's squared though. So like if you plugged in -2 there, you would get 1 over -2 squared, which is 1/4. All right, so if you punch in all these, you'll get this. 0 is still undefined. That's going to be your vertical asymptote. Whatever number throws a undefined here, whatever number will make this whole denominator 0 is a vertical asymptote. All right. So I'm going to do it in blue so it sticks out a little bit better. Now this one looks like this. All right, so this 0 being undefined is your VA. Okay, and since there's no shift, like it's just +0 right there, that's your HA. So you have an HA at y equals 0. So x equals 0, VA, y equals 0, HA. So when you actually graph this line, it's going to look something like this. Okay. So the big change here is notice that like before our rationals looked like this and they would be oppo like quadrants from one another. Well, now they're going to be kind of just like mirror images of each other if it's squared. So 1 over x would look like this. -1 over x flips it, so it looks like this. 1 over x squared looks like this. And -1 over x squared would look like this. So that's pretty important to know right there. So let's go ahead and jump to this next page. If I approach these problems, no matter what, the very first thing I'm doing is I'm looking for my VA. So it's the number that would make this whole bottom part 0. All right, so if you punched in 3 here, it would be 1 over 0. So you have a VA at 3, at x equals 3. All right, now after I find my VA, I go look at my HA. It's at -2. So there's an HA of -2. Y equals -2. All right, and so now all I have to do is kind of think about this. This is a positive lead coefficient. There's no negative out in front there. And it's a square. So a positive square looks like this, up, up. So this problem would look like this. And so your domain, you're going to have 2 pieces of your domain. One is for this left section of line. That's everything from -infinity to your VA of 3. The other is this section of line. That would be everything from your VA at 3 to +infinity. And your end behavior is what your arrows are leveling out at. If you go left or right, so as x goes to plus or minus infinity, those arrows are leveling off at the HA of -2. And so that's how I would have done that problem. Okay, this next one. Go find your VA first. This one's at 0. Then go find your HA. This one's at 3. Okay. Now I think to myself, it's a negative lead coefficient and it's a square. So my arrows are going to be together and they're both going to be going down on that VA. So it would look something like this. So now I would find my domain. So I've got two sections. This left section is everything from negative infinity to my VA of 0. The right section is everything from my VA of 0 to positive infinity. And then my end behavior, if I go left or right, so as x goes to plus or minus infinity, both of these arrows are going to be leveling off at the same thing, which is that horizontal asymptote, y value of 3. Okay, this next one, go get your VA. It's at negative 2. Go get your HA. It's at y equals negative 1. This is a positive lead coefficient and a square. So my arrows are together, both going up, up. And so now the domain, the left section, is everything from negative infinity to my vertical asymptote at negative 2. And the right section is everything from that vertical asymptote at negative 2 to positive infinity. And then if you look at both of these arrows, they're both going to go level off at that horizontal green line. So as x goes to plus or minus infinity, my y value is leveling off at that horizontal asymptote of negative 1. All right, and then this last part, they really just care about, like, when they say like the asymptote behavior, they're talking about like what these arrows around your vertical asymptote are doing. So they're really just kind of referring you back to like this right here. That's all. So this first one, a negative square, means I would have my VA and my line, they would both be going down. So it would look something like this. Okay, this next one, a positive lead coefficient and on a degree 1. So degree 1s are where they are oppo. See, look at these two over here. All right, and it's positive, so it would look like this. Really just quadrants 1 and 3 is all you care about. So you would have like your VA and your HA. And this line is going to be like quadrant 1 and quadrant 3, like that. Okay, this next one is a negative lead coefficient and a degree 1. So that's going to look like this right here. So like you would have a vertical asymptote and a horizontal asymptote. And you really just care that you're in quadrants 2 and 4 type scenario. You say quadrant 2 and 4, but that's kind of misleading. It's mainly just like completely opposite sides of the asymptotes. So I hope that wasn't too confusing. All right, and then this last one is a positive coefficient on a square on a degree 2 on the bottom. So that's going to look like this with your arrows going up, up around that VA. So like you'd have a VA and an HA, and your two sections of line would both be going up at the vertical asymptote. So it looked like that. So it's really important that you know the general shape based on lead coefficients or based on like if it's degree 1 or 2 on the bottom. So that's how you do that. And I hope this video helped.